All right, guys, let's focus in. So, chapter 7.5, the last thing we're covering in chapter 7 is solving these rational equations. So the first thing we want to do is solve this here. 3 over x plus 1 is equal to 9 over 4x plus 5. We're wanting to solve this and find what value of x will make this true. What will make both sides of the equation be equal. Now, we haven't talked about these in a bit, but we still have restrictions. Our restrictions are any value of x that would make the denominator be 0. Now, for addition, subtraction, multiplication, division, it didn't make a big difference. It didn't really have a big impact on the overall process. Simplifying didn't change anything. With solving, the restrictions are going to be helpful. Because if we solve the equation, we solve this equation here, and one of the solutions that we get is a restriction, we can immediately throw it out. We don't even have to check to see if both work, because if one of the two solutions is one of our restrictions, it means that one of the denominators would be 0. We cannot divide by 0. We can immediately throw it out. Now, the two places in this equation where we can get a restriction or have a value of x that causes the denominator, the bottom of the fraction, to be 0 is x plus 1. Because x plus 1 is in the bottom of the fraction. If this is 0, we would have a restriction. The other place where we can have a restriction is at 4x plus 5. Because if we have a value of x that makes 4x plus 5 be 0, it would cause a division of 0. Does not work. Restrictions. You're good? Go for it. So to figure out what our restriction is for x plus 1, we solve for x by minusing 1 from both sides, telling us that if x is equal to negative 1, the denominator would be 0, so x cannot be negative 1. We can do the same thing with 4x plus 5. So the first thing we're going to want to do is subtract 5 from both sides. Because our positive 5 minus 5 would be 0, giving us 4x is equal to negative 5. Divide both sides by 4. Telling us that if x is equal to negative 5/4, we would have a division of 0. It does not work. So if we get negative 1 or negative 5/4 as a solution, we can immediately throw it out. We don't even have to check it. Those will not work because they would cause a division of 0. Questions on this so far? Now, what we want to do first is if we can get these fractions to simplify, it's going to make solving a lot nicer. Because solving an equation that doesn't have fractions as either part of it or on both sides is going to be a little bit nicer. So I'm going to multiply both sides of this equation by the expression x plus 1. I'm taking this on purpose. Now, on the left-hand side, if we multiply by x plus 1, it would multiply on top because, again, we're multiplying through the equation by x plus 1, everything. So we don't have to multiply on top and bottom. It's not an expression. We will do the same thing on the right-hand side and get 9 times x plus 1 over 4x plus 5. Questions on this so far? Now, it seems kind of odd that I chose x plus 1. But after multiplying through, the left-hand side, we do have two terms being multiplied on top, and we have that x plus 1 on bottom. Well, that x plus 1 over x plus 1 will reduce. They will cancel out. which means that that left side, the denominator, has been reduced to 1. We don't have a denominator there, so that side does not have a fraction anymore. Can we reduce anything on the right-hand side? Well, no, x plus 1 and 4x plus 5 are not the same. So if I want the right-hand side's fractions to reduce, we actually need to multiply it by what? 4x plus 5. Because if we multiply the right side by this 4x plus 5, we will indeed have 4x plus 5 on top, 4x plus 5 on bottom. Since the top terms are all being multiplied, those will reduce. But we also have to multiply the 4x plus 5 on the left side too. Now it does help us on the right-hand side because that 4x plus 5 over 4x plus 5 will indeed simplify out, cancel out. Reducing both of our fractions. We don't have fractions anymore. The left-hand side, all we have left is the 3. And it's still being multiplied with our 4x plus 5. All right, guys, focus up here. On the right-hand side, we still have the 9 times x plus 1. Both denominators simplified to 1. They simplified out. And this is all we have left. This is a lot nicer to work with than having two fractions. Because now we just need to solve for the value of x. And the first thing I would do is resolve these parentheses. We can distribute the 3. 3 times 4x, 3 times 4 would be 12x. 3 times 5, this would be plus 15. Equals, on the other side, 9 times x is 9x, and 9 times 1 is 9. What can we do next? There's actually 4 different options. Because we can move the 9. We can subtract 9 from both sides. Or we can subtract 9x from both sides. Or we could subtract 15 from both sides, or subtract 12x. We need to get the variables, the x's on one side, numbers on the other. It doesn't matter which one we move first. We just need to move one of them. So if we subtract 9 from both sides, on the right-hand side, 9 minus 9 is 0, leaving us with 9x. 12x will still be on the left-hand side, but our 15 minus 9 would give us 6. Now that we got the constant terms on the same side, we'll subtract 12x from both sides. Because our 12x minus 12x would be 0, leaving us with 6. And 9x minus 12x, 9 minus 12 would give us negative 3x. And last but not least, we would divide both sides by negative 3. Negative 3x divided by negative 3 would just be x. And 6 divided by negative 3 is indeed negative 3. Questions on this here? Is negative 2 one of our restrictions? No. So it says that this value will work. It will not cause a division of 0. We don't have to worry about that. Now, if it did ask us to check and make sure this works, all that's saying is we're going to come back to the original problem, the problem we started with, and replace x with negative 2. And we just need to make sure that 3 over negative 2 plus 1 has the same value as 9, guys. 9 over 4 times negative 2 plus 5. We just need to make sure that these have the same value. Because if they have the same value, the negative 2 is a solution because it makes both sides true. Now at this point here, we can plug the whole thing in, or we can check it by hand, because negative 2 plus 1 is negative 1. And well, 3 divided by negative 1 is negative 3. So as we simplified the left-hand side, it's going to simplify to negative 3. On the right-hand side, 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. Simplifies to negative 3. And since both sides have the exact same value, we can say that that is the correct answer. Negative 2 does make both sides be the same. Questions on this here? Let's look at the next one. 2 over x plus 2 is equal to 10 over 3x plus 2. Now, one thing that we do need to make sure, especially when we're looking for restrictions or when we're multiplying both sides to get the factors or denominators simplified, we need to make sure the denominators are factored as far as possible. We need to make sure they're factored as far as possible, because if they're not, there's a chance we might multiply by too much. If we go above the least common denominator, those extra factors will become solutions, which will be a part of our restrictions, which we'll have to throw right back out. They don't work. Now, our restrictions, x plus 2 is one of the places where if that gives us a 0 is going to be a restriction, does not work. Minus 2 tells us that if x is equal to negative 2, we would have a division of 0. It does not work. And the other place is that 3x plus 2 is equal to 0. Subtract 2 first, telling us that 3x is equal to negative 2. Divide both sides by 3, telling us that if x is equal to negative 2/3, it would cause a division of 0. It does not work. So for this problem here, the two values of x we cannot have are negative 2 and negative 2/3. Now that we have our restriction, we can start seeing what we need to multiply everything by to get those rational expressions to simplify down and make solving a little bit nicer. What's one of the first things, or one thing we're going to multiply through? By x plus 2. We are indeed going to multiply both sides by x plus 2. Anything else? Yes, 3x plus 2. Now we multiply the left side by x plus 2 and 3x plus 2. We're going to get 2 times x plus 2 times 3x plus 2. I wouldn't multiply anything out at this point. One, because we do have several things being multiplied together. But also, we know that something is going to simplify on top and bottom. Specifically, on the left-hand side, the x plus 2 and x plus 2. On the right-hand side, on top, we've got 10 times x plus 2 times 3x plus 2, and that's all over 3x plus 2. And on the left-hand side, the 3x plus 2 and 3x plus 2 will cancel. But that's what we expect to happen. That's why we're multiplying it by those terms, so that the x plus 2's on the left-hand side will cancel, and the 3x plus 2's will cancel on the right-hand side. Questions on this here? Is there anything saying that I can't just go No, we can do that. There's nothing wrong with doing that. The reason I wrote the whole thing out these last two times, this time and the last time, is again to reemphasize what's happening. Because it's going to multiply on top. We get the x plus 2 over x plus 2. They will cancel. They will reduce. Because normally, and especially once we get towards the end of this lesson and the next one, we're just going to start writing it. These are being multiplied. These are canceling. This is what we have left. Because at this point here, all we have left is 2 times 3x plus 2 is equal to 10 times x plus 2. Now we just have to solve for the value of x. Here, the first thing I would do is distribute that 2. 2 times 3x is 6x. 2 times 2 is 4. On the other side, 10 times x is 10x. And lastly, 10 times 2 is 20. So we have 6x plus 4 equals 10x plus 20. Do we have any quadratic terms, any x squared terms? No, right? We don't have x squared, because if we get x squared, x cubed, we get a variable to a power bigger than 1. We got to get that equation equal to 0 first, solve from there. Here we don't have that. So we just need to get x by itself. What do we want to move first? 6x. So we can subtract 6x from both sides first. 6x minus 6x is 0. 4 is equal to 10x minus 6x is, giving us 4x plus 20. Then we would still got to get x by itself, so we would subtract 20 from both sides. Minus 4x is indeed equal to negative 16. And last but not least, divide by 4. So x is equal to negative 4. Yes. Any questions on this here? Now, again, if it asks us to check our answer and make sure that it works, all we've got to do is, again, go back to the equation and plug negative 4 in for x. Now, I showed you how we'd check it or normally do it by hand. If we want to do it in the calculator, we just have to type it in. We'd have 2 over negative 4 plus 2. And it tells me its value is negative 1. When we plug negative 4 in, we get negative 1 out. And if we do it to the same thing, do the same thing to the other side, plug negative 4 into our 10 over 3x plus 2, we also get negative 1. And since both sides have the same value, it means they're equal. So negative 2 is the solution because it makes a true statement. Questions on this here? Let's look at the next one. 3 over 5x equals 2 over x minus 7. We can list our restrictions first. Does anybody have a guess at what the two restrictions are going to be? Because our restrictions are going to be any value of x that's going to make the denominator be what? 0, yes? Where are the two places it could be 0? 5x and x minus 7, yes? What times 5 is going to make that be 0? 0. And we can show that 5x is equal to 0. 5x divided by 5 is x. 0 divided by 5 is still, so x cannot be 0. And the other spot was x minus 7, yes? What number can I subtract 7 from to get 0? 7. So x cannot be 0 or 7, because if it's 0 or 7, we have a divisibility of 0 or division of 0. Does not work. I'm going to rewrite it so I have a little more space. What do we know for sure we need to multiply everything by? 5x. Because we know we're going to have to multiply by 5x because the left-hand side, the 5x and 5x will cancel. Anything else we need to multiply through by? Well, x minus 7 and x minus 7, because the right-hand side, the x minus 7 and x minus 7 will cancel out. They'll simplify out. And that leaves us with what? 3 times x minus 7 is equal to 2 times 5x. Questions on this here? Now we just need to solve for x. So we'll simplify these parentheses first. 3 times x is 3x. 3 times 7, negative 7 is negative 21. 2 times 5x is 10x. What can we do next? Well, we can add 21 to both sides, but that's not going to help us much. What would we rather do? Subtract 3x. Because the 3x and 21 are next to each other, we need the x's on the other side. We need them away from the negative 21. And if we subtract 3x from both sides, our 3x minus 3x, 3 minus 3 would be 0, leaving us with negative 21 on the left-hand side. 10x minus 3x, 10 minus 3 would be 7x. Last but not least, we would both sides by 7, telling us x is equal to negative 3. Is that one of our restrictions? And if we checked it, we would see that x is equal to negative 3 is the correct answer. Questions on this here? Questions on any of this so far? Now you might have noticed or might not have, it said, and at the top of all these here, solve by cross multiplication, solve by cross multiplication. And we really necessarily haven't been doing that. We have and we haven't. Because cross multiplying is our highlighter. We're going to take the product of these two and set it equal to the product of these two. And I think you guys remember at least a little bit of doing this. And it's not that I have anything against cross multiplication. Because if we look down here, 3 times 7x, or x minus 7, is what I have here. 2 times 5x is what we have here, yes? And it works. And it will get us to the correct answer, and it does work for these here. The only issue with it is when we get to this here, because cross multiplication works if we have 2 fractions set equal to each other. As soon as we get more than 2, it does not work. We would have to get the 5 over x plus 7 over 4x to be a single fraction. Then we can actually do cross multiplication or cross multiply. However, the method we've been doing, that least common denominator to multiply through, will work with this. It doesn't matter that there's not one fraction on either side. It still works. We could have 6 fractions. We do the least common denominator. We multiply through. It's still going to work. I would rather go over a method, or we learn a method first that works for all of them, not one that just works if we have one on either side. Then as soon as we hit a method that, or some problems that doesn't work for that, we now have to find a workaround to get it to work. If it works for all of them, why not start there? Questions on these here? Let's look at one last one. We will finish this. We'll do this one here. We'll finish the note sheet tomorrow after this. Negative 4 over x plus 3 is equal to 5 over x minus 3. What would our 2 restrictions be? Positive or negative 3. Because the 2 places where x can be 0 is at x plus 3 and x minus 3. Now they are factored. X plus 3 and x minus 3 can't be factored or simplified any further. To solve this, we would subtract 3 from both sides, telling us that if x is equal to negative 3, the denominator would be 0. We have to throw that out. With our x minus 3, we would add 3 to both sides, telling us that if x is equal to positive 3, the denominator would be 0. We cannot have that either. So what do we want to start doing first? What are we going to multiply first? We're going to multiply through by x plus 3 and x minus 3. Because on the left-hand side, the x plus 3 and x plus 3 would cancel, leaving us with negative 4 times x minus 3. On the right-hand side, the x plus 3 and x plus, make sure, nope, x minus 3 and x minus 3 would cancel, telling us that we have 5 times x plus 3. Then our next step would be to distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 would be positive 12. On the other side, we're going to distribute 5 times x is 5x, and 5 times 3 is 15. Next thing I would do is add 4x to both sides. Negative 4x plus 4x would be 0. Telling us that 12 is equal to 9x plus 15. We would indeed subtract 15 from both sides, telling us that negative 3 is equal to 9x. Divide both sides by 9, telling us that x is equal to negative 1/3. That's it. Any questions on any of this here? Any questions on anything we've done so far? All right. We'll finish it.